Okay, so here I will talk about the absolute motion analysis. The absolute motion analysis, it's another way of saying that show displacement S as a function of theta. So it's also, so in other words, find the relation between S and theta. That is what the absolute motion analysis means. So if you solve a simple problem here, we can see the application of it. So we have a hydraulic window that has a cylinder from A to B. Then the cylinder extends at a constant rate. Whenever you see the constant, it means that the d by dt is 0. At half meters per second, determine the angular velocity and an angular acceleration of the window at the instant the theta is 30 degrees. Okay, so this one is the absolute motion analysis. But before telling that, let's do this way. So the question asks about the omega, which is d theta by dt. And it asks for the alpha, which is d omega by dt. Okay, but the main problem is that theta is unknown. Okay, we don't know the theta. But, so we know S. And then if you find S as a function of theta, then we can find the omega and as well as the alpha. But if you look at it here, then this S and this one and that one, this one makes a triangle. And for this triangle, we can use the law of cosines. Which says that S square is equal to 2 square plus 1 square minus 2 times 1 times cosine theta. Okay, so that will be that S square is 4 plus 1, which is 5 minus 4 cosine theta. Okay, but again, we need d theta by dt. So let's do it this way. If I take the d of dt of cosine theta, that will be negative sine theta, d theta by dt. As you can notice that from here I can get d theta by dt. So what it means is that if I take the d by dt of a whole equation, take d by dt of this equation, and then we can get the d theta by dt. So let's do that way. So d of dt of s square, and then d of dt of 5 minus 4 cosine theta. The first part makes 2s ds by dt. And the right hand part makes d by dt of 5 is 0 minus 4. And cosine theta, we set that negative sine theta, and d theta by dt. Okay, and then positive, and then ds by dt, this one, it is actually velocity. Then the velocity is given here as 0.5 meters per second. Change of s with respect to time is 0.5. So that's 0.5. And that is a constant. So it will be that 2s times 1/2, that will be 4 sine theta d theta by dt. And I can show that d theta by dt is s by 4 sine theta. Okay, that is the d theta by dt. But the question says, and this is omega. The question says that find omega when the angle is 30 degrees. So s is unknown, but I know that s squared is 5 minus 4 cosine theta. Okay, and then from here, at theta is 30 degrees, then s is 5 minus cosine 30. And then cosine 30 is, I checked, 0.866. And then I have 4 here times 4. And that will be 5 minus 4 times 0.866. And square root of it, 1.24. Okay. And then from here it follows that omega is 1.24 by 4 times sine 30. That is half 2 and then 0.62 radians per second. That is the first part of the question. The second part of the question says that they find the angular acceleration. And then I know that the angular acceleration is the change of omega with respect to time. And then I also found that omega is s by 4 sine theta. And then I need to find d omega by dt. Okay, and then let's do that. So we will need to find d omega by dt. That will be d, so 4 sine theta ds by dt minus s into d 4 sine theta by dt, and then divide by 4 sine theta squared. That is the fraction. And then for fractions we use this differential rule. And then ds by dt, we know that it is 1/2. And then 4 times sine theta by dt, that will be, if I write 4 sine theta minus the second part, which is s times 4 times d sine theta by dt is cosine theta times d theta by dt. Okay, and then divided by 16 sine theta squared. And then again we have the d theta by dt, which is omega. So the rest we will just replace the values. That will be 2 times sine 30 minus 4 times the s value. S we have found, which is 1.24 times cosine 30, and then that times the omega value, which is we have found as 0.62. The whole divided by 16 times sine 30 and squared. If you solve this part, let me do it one by one. So this one is 1/2, this one is 0.866. So then if I do these calculations, 2 times 1/2, which is 1 minus 4 times 1.24 times 0.866 times 0.62, that one divided by 16 times 4 by 1 by 4 is 4, then negative 0.415 radians per second squared. Negative value just means that it is a deceleration. Okay, so this is the end of the problem.